Hey, you want some ice?
Yes, please.
Okay. Okay, I know we made some ice a while ago. Hey, when was the last time we made some ice?
I don't know. About a month ago?
It's cold in there, so we should still have ice. Hey, do ice last in the freezer?
Well, it doesn't last outside the freezer.
Duh, I know that. So we had ice a month ago, and now there's none. So where did it go?
How am I supposed to know? If we're out, make more.
This makes no sense. I need a scientist.
It's iodine, guanine, cytosine, and thymine. Science you find in the city. Energy's discrete on the corner, on the street. It's science you find in the city. It's oscillators, regulators, emulators, generators. Science you find in the city. It's time to explore what science is for. Out the window and beyond the door.
City Science with Mike Davis.
Excuse me, Professor Mike?
Yeah, hi. How are you?
I'm good, thanks. Look, I had a question, and I think you could probably answer it for me.
Okay, what can I help you with?
Well, I just wanted to ask you, what are you doing?
I've got a hypothesis for blowing out candles.
With one of these?
Yeah, with one of these. I mean, get to make observations and blowing smoke rings. That's kind of cool. Well, I hadn't thought of that.
Well, it's just another thing to try, I suppose.
Yeah.
Look, I had a question.
All right.
Okay, I'm here because I'm wondering why my ice cube in my freezers are getting smaller.
The ice cubes in your freezer are getting smaller.
Yeah.
Okay, how long are they in there?
Like a month or so?
A month? All right, all right, all you're doing is you're suffering from a phase change.
I'm not gonna need a new fridge, am I?
No. It's a phase change, that's all. Okay, I'm gonna have to show you what I mean. Okay? Just come with me.
Nice setup.
Thanks. Here, put these on.
Thanks.
Okay. Most people are very familiar with this phenomenon. This is a little bit of ice sitting out here at room temperature.
Well, it's melting.
Yeah, what's it turning into?
Water.
And what was it before?
Water.
Yeah, exactly. This is a physical change. You see, it was water before, and it's water after. We changed its form, but not its identity. Now, I've gotten something else here I could show you.
Another physical change?
Yeah, this is something a lot cooler than what you just saw.
Cool, dry ice.
This is dry ice. This is the solid form of carbon dioxide. And compared to this, everything in the room is really hot, including this water. So I'm going to put some here into the water. And a little bit more for fun effect. And you can see some of our typical mad science stuff. So all of these bubbles that are coming up from the bottom, where I dropped the dry ice in, are carbon dioxide. This is so hot it's turning right into a gas, and that's called sublimation.
Now, the dry ice is warming up. It's releasing carbon dioxide, which are in those bubbles down there, right?
Yep.
Now, is it releasing carbon dioxide as it sits on the countertop?
Yes, it's doing that too.
It's just hard to see it, you know. To really visualize that there's a gas.
There's another demonstration that can make that more obvious.
Yeah?
There's an 8th grade student at Finkel that can make this really easy to see.
Dry ice is a solid form of carbon dioxide. Now, it has a temperature of -74 degrees Celsius. I like working with dry ice. It's just a fun thing to use and do experiments with. The room temperature is much hotter than that. It sublimes. That means that it turns directly from a solid to a gas. Now, adding this water will make it sublime even faster because the water is much warmer than the room, and creating this cool foggy effect. Dry ice with soap is one of my favorites too. It makes pretty cool bubbles that you could play around with and pop. Putting the soap over it is like putting a soft lid over the entire thing. So as the amount of carbon dioxide increases, it creates a bubble. Pretty neat to play around with. You Be the Chemist was the name of our chemistry lab program that we created. We did a lot of experiments, messed around with chemicals, and it was pretty fun. With a flashlight, we can make it look really cool, like a crystal ball. With You Be the Chemist, I also went to the chemistry competition where they asked me a lot of trivia about chemistry, and there I got second place. I just got accepted to Jones College Prep, and I'll be taking some pretty advanced courses. All my classes are honors levels there, so I think it'll be pretty tough and quite a challenge.
This is not carbon dioxide. A lot of people guess that. This is steam, just condensed water vapor, okay? So when you're outside and you breathe in the wintertime and you can see your own breath, does that mean your breath smells? Does it mean your breath doesn't smell? No, does it mean anything about your breath? It means nothing. What it means is you've got a little bit of moisture in your mouth that's escaping, and it's freezing right in front of you, making a small cloud. And that's all this is. This is like a little cloud. It's condensed water vapor. So when something like carbon dioxide changes from being a solid to being a gas, that's called a physical change.
So when we started, the carbon dioxide was a solid, and when it's done, it's a gas.
Right. Through the whole process, it's still carbon dioxide. And this particular kind of physical change is called sublimation. And there are other kinds of physical changes too. For example, when a solid turns into a liquid.
Melting.
That's right. And the reverse process?
Freezing.
Very good. Sometimes you have a small puddle getting smaller and smaller and smaller.
Evaporation.
That's right. That's when particles have enough energy to escape one another into the gas phase.
Now, can a gas particle form into a liquid?
Yeah, have you ever seen the outside of a cool glass?
Yeah, that's condensation.
You got it.
Now, can a gas particle form into a solid?
Yeah, it can happen, although it's kind of rare. I have an example right here. This is called iodine. And what I have are these little crystals. They are subliming from the solid phase into the gas phase, filling this space, and then redepositing on the top of this watch glass. That's called deposition.
That's pretty cool looking.
Yeah. So now we've got two choices. We can watch a liquid evaporate slowly or quickly.
Fast, because time is money.
All right, let's go to Fermilab. Hi, Jerry.
Hi.
This is my friend Yao.
How do you do?
Hello.
And we understand you do some liquid nitrogen work.
I do lots of liquid nitrogen work. My nickname is Mr. Free, so I get
Okay.
to do lots of great things with liquid nitrogen.
Well, can you show us some stuff?
I can show you some really neat stuff.
Let's put some glasses on.
First of all, we'll get our glasses on.
All right.
What I have in the container here is liquid nitrogen.
Okay.
And first, we'll give you a chance to see what liquid nitrogen really looks like here. And I can do that by putting it in a bag like that, where you can actually see what liquid nitrogen looks like.
And that's it. It's
That's
it's
just a clear liquid. Almost looks like water.
Yeah.
Now, the few things you notice is you see this stuff here. Well, that's not nitrogen. That's actually water vapor condensed out of the air, because the nitrogen is so cold, it's condensing the water vapor right out of the air.
And this is not coming from the bag.
No, it's not coming from the bag.
That's
It's
right.
coming from the air itself. And inside the bag, you see that the nitrogen there is bubbling. Well, it's bubbling because it's boiling, because everything's so hot to it that everything makes it boil. And it's that bubbling is it's changing from a liquid to a gas. When I touch it with my glove, I'm actually causing it to boil more, because my glove is so warm to it that it causes it to boil. Now, it is very cold.
Okay, so how cold is it?
Well, we can demonstrate that
All right, we got a
by
thermometer?
putting a little bit of the liquid nitrogen on a thermometer I have here.
Okay.
So you can actually see the temperature of the liquid nitrogen.
Oh, look at that. Going around.
It keeps going around.
So how cold is it?
Stop?
It'll eventually stop. It gets to be about 40. No, it's
That
not
doesn't
actually
sound
40.
right.
No, it's actually minus 320 degrees Fahrenheit, or minus 196 degrees Kelvin. or
That's
centigrade.
colder than anything I can imagine.
Yeah, it's very cold.